The first question that I see is, the how-tos are a great resource for learning the language, however, they don't exhaustively cover things like, for example, compiler directives. Will the how-tos get some love in the short, medium term? Yeah. So just so people know what we're talking about who aren't in the beta, when you download the compiler, we have this how-to folder. You don't have these files are mostly trash that's in here because I'm a developer. But you have some number of folders here, and one of them is the how-to. And this has a bunch of examples organized by number. The executables aren't, and the PDBs aren't here, it's just source. But it's organized in roughly the order that you would read them. And it covers a bunch of things about the compiler, and then there's folders for multi-file stuff that Windows likes to put at the top, but you would do them in the appropriate order. These cover a lot of stuff. They do not cover everything, and there's two reasons why they don't cover everything yet. One reason is just because I haven't gotten to that. And, time is limited and all that. And those are things that can be pretty straightforwardly remedied. And I like writing documentation a lot of the time. Sometimes it's a bummer, but I actually like it because a big part of why software is so terrible is that nobody documents anything, but even deeper than that, nobody cares about communicating anything. And that is like the deepest problem that we have. And it's actually it's not just a societal problem, it's a technological problem, because communicating deep technical information is actually very hard, right? And so how do you do that? That's an interesting problem. So it's all just to say, so then the reason that I like writing documentation is because it's helping to address that problem. Like in the way that the design of this programming language is like, here's a design idea that I haven't seen done, let me put it out there. The way it's being documented is like, this is how I wish a lot of things were documented, and they're not. And so let me try this out and just see what happens, right? Now, of course, the language has a lot of features and a lot of detail, and so the documentation would be a lot, and I can only do so many things in a day. So it is not complete. So now, so part of the reason, though, that some things are not complete is just that, sometimes we put in features that are kind of temporary, and I'm like, I don't know if this is how this is going to go. And so we don't document them or even encourage people to use them at the time unless they have specific problems, and we wait a while to see how it plays out. And sometimes after waiting a while, we decided it was bad. Sometimes after waiting a while, we decided it was good. And sometimes after waiting a while, it's like, oh yeah, what was that thing? I totally forgot about that. And that third category is probably the majority category. So sometimes when things aren't documented, it's like that. It's like we just haven't been thinking about them very much. Okay, however, what would be a very concrete way to move forward in terms of filling in these holes in the documentation, which we have done, in the past let's say in the past 4 months, there have been a couple documentation drops. Maybe my sense of time is off, but it's something like that. And we could do another one for sure. The question is just what's missing and what is most effective to cover. It sounds weird, but it's sometimes, it's hard for you as an author of something to know what's missing in terms of an explanation of it. It's actually a skill, and you can develop that skill, and you can find a lot of things, but it's also labor intensive. So it's easier if people just tell me what is confusing. So if you guys, as the beta community, want to start a thread on the Discord and just make a list of, these are the things that we wish we understood that were not currently documented or are not documented well enough, we can prioritize that list and just pop the top things off the list and cover them, right? So I think that would be a positive thing to do. Okay, let me pour the tea before it oversteeps. That is pouring it straight into the milk, which is crazy. Oh my God, I made too much water. It's up to the very top. Oh no. We're gonna have some dignified slurping of tea happening here. When will Simp get other graphics backends like DirectX or Metal? The main reason we haven't, oh, well, let me finish the question. Is this prevented by shader translation being done? Is that something planned before or after release of the game? No, so let me just show again. I'm in the mood since there's not that many questions, which is actually good, kind of, or maybe it's bad. You know, so Simp is just our little graphics API that I made. And the goal, like, again, I'm trying to fix all these problems at once, right? And one of the problems is just that to get anything on the screen is a complete nightmare. And so the idea behind Simp is like, how do you do stuff that people want to do? That's, you know, basic things like text and graphics and all that, and how do you do it in a portable way? Because the examples that I had seen, you know, through my game development career, where people try to make generalized things that are cross-platform, is stuff like SDL, right? But SDL, if you're going to draw graphics, you use like SDL GL usually. Like maybe it had its own graphics thing, but then that didn't go anywhere. I don't know. But then you're just using OpenGL, and that kind of sucks. And what about platforms that don't support OpenGL and all that? Now, I guess since then, so there's something called Raylib that people talk about that I don't know what it is. Maybe that is a similar kind of an API. It sounds like it's for raycasting, but I don't think it is. But it's called Raylib. Maybe it's made by someone named Ray. I don't know anything about it, but that's just the goal there. And so the only backend right now is OpenGL, but that's not because it has to be. That's because, again, time is limited, and it's like, let's try to figure out the API and how to keep things simple while performing discrete tasks. Because there's a trap. The trap that modern graphics APIs have fallen into is that you need to write a goddamn shader to do anything, and everybody's shader language is different. And so now, like even before, it would have been complicated to do a cross-platform thing, and now it's insane, right? And so the way that we approach that is, it's sort of like fixed functionality, and then you program, like it's like I'm drawing a certain kind of bitmap, or I'm drawing text, or you know, whatever. There's like basically 3 or 4 things that we call shaders, but they're just like a very hard-coded set of functionality. And the goal is to make that usable by as many people as possible, and then, well, within reason, right? And then if you want to do something complicated or extra, then maybe you start to think about how to interface with the back ends. But we do as much as we can without you having to do that. And so far that works fine for, you know, I'm not going to write a commercial game using the Simp interface, but would I prototype a game to bootstrap it to get it to the point where I needed better rendering? Yes. Yes, I would. Or like, would I write Discord using it? Yes. So it's pretty good in that department. But because the priority was figuring it out, there aren't a lot of backends. And the thing about backends is they require maintenance, right? And so that's the reason why we just haven't done it yet. If somebody wanted to contribute one, I wouldn't complain. The thing is, there is a remaining question in Simp, which is, like, obviously we can do, I'll show you the example program. We'll make the text a little bit bigger because people always complain. So, you know, this is the program that you just saw, right? And the whole program is 200 lines, which is longer than I wish it was. But you have to do stupid crap. Like, to even do anything correct on Windows now, you have to do some stuff. Why? Because the operating system is broken, basically, right? But, you know, so there's things like that. You have to respond to window resizes. Can we simplify this out in some way? Maybe. There's we actually could simplify this out, but then if you wanted to respond to events, you'd be relying more on magic. And so there's a fine line we try, like, there's a kind of a framework that gets you started, but then you can do whatever you want. And there's a kind of framework that's like gets you started, but then as soon as you want to do anything, you can't do it. And we don't want that. We don't want you to not be able to do things. And so that's sort of the fine line, right? Anyway, so we respond to events here. We draw a frame. We take screenshots, I guess. I guess that's in here because we wanted to test it. That's like a substantial portion of the program is this comment and taking, right? Like the screenshot code is from line 64 to 91. Yeah, it's 15% of the program. Anyway, and then to draw a frame, this is what I was getting to. So to draw a frame, we have these like fixed shaders. So we just say shader for color, and what is that? That's like vertices with ARGB on each vertex. Is that smooth brain and stupid? Yes. But that also enables portability without you having to worry about writing a frickin' shader all the time, right? And then to draw text, you say draw text, right? And then you say set shader for images, and that's a very specific thing. It's ARGB color plus diffuse texture, right, or times diffuse texture, with, you know, user specified UVs, with or without alpha blending. That's like a parameter here that's implicit. And so we have fixed functionality like that, and we only have a few of those so far. And so this is the question of the future of Simp is like, how many of those do we make? And we don't have any for 3D yet, by the way. This is all just 2D. 3D is the same thing, but it's always just gets a little more complicated, so I didn't want to worry about it yet. So how many of those do we do versus adding some portable outlet that lets you define your own shader, right? And what might that look like? Well, we might transpile from this language into whatever the backend shader language is, right? Maybe. But that starts to get complicated, and maybe I don't want to think about it, and maybe we don't want to do it at all. And so that's like the question there. All right, I'm going to deal with my T for a second. Feel free to ask follow-up questions if you're in the beta in the Discord chat. If you're in Twitch, I am not seeing anything you type yet, but we may at the end if there's time. Oh, I just spilled it. Oh no. Oh no, I bumped the table. All right, well, I didn't steep it that long. I just spilled it again. I didn't steep it that long, so it's going to need honey for some flavor. We like that. Okay. How does as using for inheritance or composition work internally? I mean, the way you ask that, so first of all, the reason it's as using, which seems awkward, again, let's try to illustrate for the non-beta peeps who are here. What's a good, I mean, we could just go to the Sokoban game, right? Because we do this all the time. This is a very simple, straightforward thing, right? But so let's go to a very concrete entity type, like an object, like a mirror. Yeah. So anytime we define an entity, you know, we do something like this at the top. And what this does is, in combination, this gives us functionality like you would get in, you know, a subclassing in C++, for example, but it's more orthogonalized and, well, it's orthogonalized because as is one feature and using is another feature. And we used to do it all inside using because I was like, hey, it'll be ergonomic to only have one thing. But then there are some cases where you don't want that. So I broke it into two things last year sometime. Maybe the year before? I don't know. Anyway, But you're talking about them as though they're one thing, which I understand that, but it's best to understand that it's two different things, right? Because the reason we implement it this way, as opposed to just, because we could have just added a programming language feature that's just like, hey, there's classes and subclassing like C++, but we don't do that. And the reason is because these operations are actually more useful in wider contexts and more similar to each other, right? So what using says is just that I can use the names inside this thing as if they were members of my own struct, right? And what as says is that if you're ever in a situation where you're trying to type check and I pass you a mirror and you want an entity, we're going to allow that, right? And this isn't that new. Various programming languages have some flavor of it. I think D is the first one that I remember seeing, but you know, there's others. This is not that rare, and this is not that rare, although the way that it works tends to vary in different languages, right? Like what you're allowed to do using on and all that, and how it works. Anyway, so all this line says is, well, we've got this declaration here, that's an entity, and we can use its names as if they were top level in this struct declaration. And also, if you ever type check, for example, a procedure parameter or whatever, and you want an entity, and I give you a mirror, that's okay, provide this entity, right? So you want to think about it as two separate things. I agree that you use them in conjunction a lot, especially if you came from C++ and you're used to thinking about them that way, but they are useful separately. What's the current state of closures making it in? The current state is I almost put them in 2 weeks ago, but then other stuff came up. Or, you know, there's, okay. But then the other reason I didn't dive into it was because I'm not totally sure. How's the lighting in here, by the way? Do we need, it's pretty bright, right? That's fine. I'm surprised at this camera. Anywho, yeah, I really should have cleaned the lens before that interview with the streamer dudes. Oh well. What were you talking about? Closures. So there's basically a roadmap, and the roadmap looks like this. Like, because there's also the question, how do you transition the compiler to a state where you have closures? And everything's smooth and you don't break people's code and all that stuff. And it goes like this. Step one would be to introduce a type that's basically a function pointer plus a data pointer, right? So here's a fundamental problem, right? If you have a closure, where's the data stored, right? And there's two, in a systems language like this, you could have two fundamental choices about that. One choice is the data is just stored contiguously in memory with the function pointer, and then however much data is stored there, that makes the thing bigger or smaller. So in that case, a closure would basically be a struct with the function pointer in the first member, right? Let's draw this out, right? Like, let's say, I'm making this up. The syntax would not be anything like this, but let's say you said like capture A, B, C for, I don't know. This is not at all what I'm thinking for closures, but to get the conversation started, right? Just, this is kind of verbose, ugly thing to say. And let's just say this A, B, and C are things from the outer scope. We're sort of emulating C++ syntax here, but I don't want to do that. But this is familiar to people maybe, right? Okay, so one choice that you would have is, you know, you make some struct that's anonymous, but we're gonna call it anonymous because we're drawing it out. And it would be like, well, you would have the function pointer, I don't know, it's the size of a pointer, so we don't care, right? And then you have A, B, and C where the types, because we captured this from some outer procedure, and so maybe A was an int and B was a string, and C was like a hash table from string to vector 3, right? And so this is one choice that you have about how it's implemented as a compiler writer. But the thing is, this choice has consequences for the people, right? And one of those consequences is that now every closure is a different size. And that means that you don't necessarily know things about it, right? On the other hand, and it's unclear, but on the other hand, maybe thinking about memory is simpler. I'm not sure, because these are all packed into one contiguous block of memory, and it's probably by value most of the time. But, so what is the consequence of that, though? The consequence of that is you start running into problems like you have in C++ with standard function, where now anything that uses this thing has to be polymorphic. So if I have anonymous 1 here, right, and then I have anonymous 2, and that's just got some different stuff. Let's just say this is a string in, I don't know, this is a array of 10,000, 100,000 void. So these two things are different sizes. So now if I have a function, and I think it takes, oh, I should have said like bool up here or something. I omitted the return value. Sorry for people who are confused. So what we would like, okay, here's the thing. C++ has this problem where closures were introduced after the language already existed. So they had a way of passing functions around. It was called function pointers. And then now that you pass a closure around, if you want a closure, that's like a different thing from a function pointer. And so if you're doing it old school, you can't take a closure. And if you're doing it new school, you have to do header-only programming because this thing is defined in std and like whatever. It's a mess, right? So what we would like is from the beginning is that you just say this, right? And now here's where it gets a little complicated, but like, what does this mean? You want this to be something that will take either of these things without doing any other shenanigans, and it just works cleanly and smoothly. But the problem is, if these are essentially structs, this effectively has to be a polymorphic type, which means any function that takes it has to be polymorphic, right? And you could do that. And in fact, a lot of programming languages make that choice, or a lot of modern ones. That doesn't seem that good to me, right? And so the idea that I have is just the following, and this is better in some ways. I think it's better in a lot of ways. It may be worse in some ways, though. We'll see. Instead of doing this, all closures are the same size, and they've just got a proc, right, and a data. So, and they look the same from the outside to everybody. And that way, if you have a procedure that takes a function pointer, it could take different closures, and they're not polymorphic. Now, how can they all be the same size? Well, the answer is because this data pointer just points at this, right, or this. Like it makes a this. It makes a substruct that doesn't include the procedure pointer and just has the data pointer and all that. So those are the two fundamentally different ways that you could implement it, and I'm leaning toward the second one. And so the reason I went into that whole spiel is just to say, step one of adding closures would just be not even to have capture or anything, but we would just add a procedure type. And maybe it's what you get by default when you say something like this in a function parameter. And it just looks like this. And that has some consequences, right? It makes it bigger. It changes the calling convention. But I don't think people are too worried about size because like function pointers, they're just not the majority of your data, right? And then, well, okay, what about when I declare a function like, well, let's make a different function that doesn't have, right? What about a function like this? How big is this? And I think the answer is just there would be some directive called bear or whatever. Or we would actually probably flip it around where, you know, if you declare a variable that looks like a function, is it 8 bytes or is it 16 bytes? You would either have a direct, depending on the default, you would either have a directive to say, no, it's 8, or you would have one to say, no, it's 16, right? And maybe we start with 1 and flip it eventually just to maximize compatibility, right? But if a procedure is constant, unless there's some syntax for declaring a data element in here, which we could add, we would just know that it's 8 bytes. And we would auto cast up between this and a closure by just putting a null data pointer, right? So that gives you automatically better ergonomics than in C++ because you don't have a weird polymorphic thing, and then both closures and non-closures both implicitly cast to that thing. Now, well, and then the other reason I say that's the first step is we already have a use for that, which is, for example, we have this common type called an allocator that has a proc and a data, right? So the reason why I like that is it's not only useful for closures specifically, because when people think closures, they think about capture and whatever. And I think it's worth tweaking the viewpoint a little bit because it's more nuanced than that, right? So the observation that led to closures, like in the 1960s or whatever, was that it's often useful to just supply data with your function because the function can be data driven and decide what to do based on the data, right? That's been true forever. That has changed though. Now in the world of multi-threaded programs, it's like you don't really ever want to not have a data pointer, right? It is bad practice to not have a data pointer with your function because if you don't, you're probably reading globals, and then you've got a thread safety problem, right? Now, in this language, we have another facility called the context. So you could also be reading from the context, and that is thread safe. However, you don't want to like jam every single ass variable in your program into the context just to get thread safety. Like that's stupid, right? So anytime that you have a function that's like a callback or that's dispatched to or anything in modern programming, like the word modern I use disparagingly usually, but one thing that's correct is like, yeah, you want a data pointer, right? And so that's the way that I'm designing the feature is like, you wouldn't just use it in the Lisp nerd closure way, but like also just as a practical matter, I want a frickin' data pointer, right? And so, you know, what would that look like after this? Let me just, I don't want to edit my system files here, so let's go to a new file. You know, even on my own use, when I make a new Emacs buffer, I just type spam like that. And there's not a zero probability that I would retype some spam that I typed before to like put some passwords or something. So someday that might happen. Is that just like I spam a buffer and it's like, oh, your bank account now has $0 in it. Okay. Wow, that tea is good, even though I didn't steep it that long. I like it. Okay. So, by the way, let me know in chat if these answers are too long, but I like going into like more thorough answers sometimes, but I see there's more questions too, so we might have to blast it. Anyway, so this is what it looks like now. And basically, if you remove the need for a separate data pointer, then your parameters don't have to have that data pointer anymore. Except it would, like, because we're trying not to be too magical, there's two ways to do this, right? You could say, I don't know, this.data, right? But you actually want to be type safe about this within the function. I declared this as a void pointer down here. Oh, and just to finish the previous thing, instead of this being a struct, it would just be, you know, we might make a new type for it. Actually, no. I mean, it would just be allocator proc. An allocator proc would just have a data pointer. So that would simplify away, but it's really the same thing under the hood. But then, you know, in all your user code, because right now user code sort of has to pass the data pointer separately if it wants to, and you wouldn't have to do that anymore. But you don't just want to, like, if we don't give you type safety, you would have to like cast to some unknown struct, right? And you would prefer maybe even to have another parameter list here instead that says like, this is what my data pointer is, or actually you don't declare the pointer part. I don't know, guys, but like that would be, the next step would be this part, right? And then the next step would be maybe adding captures, which maybe we would never even do, because I feel like you should be able to implement captures in user space. And if we don't do that well enough with the metaprogramming, we should improve the metaprogramming, right? Anyway, so that's sort of the roadmap. And the point is, I almost did the 16-byte function pointers a couple weeks ago. It's just, like, on the one hand, it's good. Is it really that good? Like, anytime I'm complicating the core, like just the type system and the core of the compiler, we're already complexity bound, right? Everything in the modern world is complexity bound. And so, it's like, is that really the right thing to do now? And I just found other things that seem better to do now, is all. But that's the vague plan for possibly doing that. What's the size of 100,000 void? 0. Yeah, so that array would have been 0. That was the joke. That's insert Simpsons guy meme. After everything finishes compiling, and the status report has been printed, is there a way to run a metaprogram? Is there a way to access the status report fields? The values. We don't really, okay, so we don't really provide that data yet. Like right now, the last thing you can really do is officially is during the complete message that your metaprogram gets, right? That said, you could like sleep for a minute after that message and then do something, and nobody's stopping you. But like that's the last official event. It has been the plan for a long time to provide more diagnostic information to your metaprogram, because I'm very interested in being able to understand programs, see them clearly, see when things are right, see when things are wrong. And we actually took a step toward that recently in the last couple betas that happened in the last couple of weeks. What am I thinking of? Guys, I work on so many things. I just never even remember. Either that or I'm senile, right? So we added a message. What was the message we frickin' added? Oh yeah, the polymorph report. So this was like, you know, we were having some discussions internally and we were like, yeah, there's a lot of polymorphs. So I worked on the back-end deduplication, which now helps a lot in terms of reducing the amount of code bloat due to polymorphic stuff. But while I was doing that, it's like I could have hacked in some profiling for myself that's in the compiler with an ifdef and only I know about it, or I could implement it in a way that provides information to everybody. And so now people have this report and it's like, here's all the polymorphs and they're in data structure form and you can see everything, right? And so what I would like to do is more messages like this. This comes before the complete message, right? And so I would just like to supply more of these that have more useful information. But right now there aren't more of them. But they're not that hard to add usually. So yeah, like you could imagine another one that tells you like how much time it took to compile every function, right? That's more complicated than you would think because the compiler is very nonlinear. And so it would be like adding together timers from various sources, and we would have to make sure we're like not missing stuff and whatever. But you could imagine that and that being useful, right? And so we'll probably provide more information like that in the future. A lot of features rely on debug mode checks to verify correctness. People are complaining about mic volume, so I'm going to do the usual thing where I turn it up and then everyone will say it's too loud. So there we go. Yeah, we're not clipping, so it's hopefully fine. For example, verifying maybe by reference. What is a perf difference between debug release for a large program like Sokoban? What are we doing from preventing the difference from becoming so large that debug is not useful? Yes, okay, that is a very good question, actually. This is the kind of question that prompted the creation of this programming language because people designing other languages did not care enough about this question. So the question is, what is the perf difference between debug and release? I don't know how well this is going to come across because we're streaming at 1K bit rate, right? But like, let me just start up the game. Our startup time is still longer than I wish it were, although we did fix some bugs about it. So this doesn't have a ton of neat graphics right now, but it's actually, actually you can't see, but there's a whole giant overworld invisibly under where I am. Let me go down to somewhere a little more. No, we'll leave it here. So anyway, Control F. So I'm still not topping out the frame rate here, but that's in part because I'm streaming and in part because we have really dumb code that has a high per entity overhead, and even though there's not final art here, there's just like a bunch of entities. So, you know, we are, I mean, I can't really see the number that well. The average is like 20 milliseconds per frame right now, which is, again, way too much for ship, but that's what our release build is right now. We can go into another level, right? That's more, whoops. So that right there is the overworld. It's less developed graphically. Here's another level that's more developed graphically, although again, not final. This is about the same frame rate. A little bit slower, actually, which is interesting. But, you know, okay, so it's playable, right? All right. Now, okay, the reason I said the question is a good question is because what has been happening in compilers and programming languages recently is that debug modes for things are so much slower than release modes for things that debug modes are like no longer interactive and they're very frustrating and hard to use, right? And we don't want that. So we actually have two debug builds right now, and I'll show both of them. So this is going to be the LLVM one first. It takes longer to compile because it's using the LLVM backend. And thank God we're only using LLVM 11 because from our tests with LLVM 15, it's 4 times slower. We're going to see if we can do things about that, but it's literally 4 times. Every version is an extra 1 time slower. I don't know. Anyway, so here's a debug build. I'm just starting it up into the overworld again. It's going to take longer to get into the game, and the frame rate will be lower, but it's still interactive is going to be the point. I actually didn't time how long it took to start up before, but you know, that was longer, but not unreasonable. And then I can move around, and again, I'm not sure how well Twitch is doing this. I actually should check for dropped frames at this point because we had such a, no, we're good. It's playable. This is the LLVM debug build, and let me go to that other level we were showing. What's the frame rate? 36. So we are not quite twice as slow. I actually don't know if you guys are getting the game audio. And here we're 43, 49 sometimes. So again, we're not quite twice as slow. Now, that's not an apples to apples comparison with code that is like straight up CPU bound all the time because we're doing a lot of graphics there, but it's not unreasonable, right? So this is the x64 backend, which is not optimizing at all. It compiles substantially faster than the LLVM backend, so I use this all the time. This will be a little bit slower even again, right? So I'm just giving you the range. I can sort of see myself animating still. Again, I don't know what this looks like over Twitch, but okay, so now we're at like 53, 55, so we're like 2.5 times slower instead of twice as slow, which is a lot if you're benchmarking. Yeah, and we're around 60 milliseconds here. So, but the plan for that x64 backend is also both to speed it up. Because the compiler, by the way, is about twice as slow as it was a while back, and I'm not sure what happened, so we have to debug that. But yeah, it's just to say the plan for the x64 backend is to add optimizations and stuff. And optimizations is one of these things where there's a power law, where there's probably a few small optimizations that don't even take that much time to do that give you a large benefit in terms of runtime, right? But anyway, the point is, what you just saw there is roughly in line with my expectations long term, is just, if debug is like 3 times slower than release, that's not that bad, right? It's still well interactive. You can still do things that you want to do. And okay, so what was in that debug? So we don't have the specific maybe by reference test that you talked about on there, but that does have at least all of the following things turned on and maybe some other ones. It has user level stack trace. So like we're pushing a stack trace node on the stack every time you call a function. It has array bounds checks on arrays and strings. It has, I should look. I felt like there was at least one, what am I looking for? Why am I not seeing, okay, here we go. That's because it changed at some point. Okay, so math bounds check we also don't have, but it has null pointer checking on. It has cast bounds checking on. It has array bounds checking on. It has user level stack trace nodes. And then maybe a little bit of other stuff. So all these things are pretty slow because, adding if statements every time you access an array is like, it slows down the array access by quite a lot. So yeah, that just gives you the idea. If there's any more, I feel like that was a long answer. If there's more question as a follow-up, feel free to follow up. But the bottom line is, if debug build becomes interactive or painfully slow, I consider that a failure case that we have to do something about. Like, I don't want to end up in this place that all these other programming languages are at. Follow up on as using, are the entities of Sokoban stored in multiple arrays? Yeah, so, okay. So in the modules, there's a module called bucket array, right? And the job of this is to store, a bunch of the same type of things, or, it could be things of the same size, but we use static type checking on it. So really it's meant for all the same type of thing. And I was going to say they're a bit mask, but I was so lazy, it's just bools. saying which slots are occupied. I really should. I mean, the thing is, it has to, yeah. I mean, yeah, it's fine. It's just a little bit messier to have it not be bool, but you save space. But we use these to store these guys. And then let me see if I can find the file. It's dynamically generated at compile time, actually, because what we do is we look at what are all the entity types in the game, and we create a bucket array per entity type statically at compile time, right? So where is it going to be? I haven't looked at these files in a long time. Added strings W3, yeah. So, and I put these underscores in front because I was paranoid, but really we don't need them. You could use the same name as the entity type. So like literally every entity type in the game, of which there's a bunch at this point, has a bucket array. But I make it this thing called type erased bucket array. And the reason I do that is because I want to alias this. Actually, it doesn't really have to be that now. I could cast it in the code. But this is basically the same thing as a bucket array. And then see here, this voidified bucket arrays gets placed on top of that. And that's what lets me index by entity index. Okay, so let's go back to bucket array for a second. Because this is using static type checking on the parameter, every bucket array of a different entity type is a different type of bucket array according to the type system, right? So you have a bucket array of guys and a bucket array of mirrors and a bucket array of like swords or whatever, right? And that's actually very good for gameplay code because very often it's like, let's iterate over all of the teleporters and see if anyone's standing on one of them. Like the gameplay code wants to do that all the time, and this makes it a very easy local iteration because all these things are right there. Okay, but what if we want to say entity type 5, give me all the entities of type 5, give me all the entities of type 6, give me all the entities of type 7 or whatever, right? How do you do that? Well, even though these bucket arrays are different types according to the type system, we know they're the same size. Like I, as the author of the program, know they're the same size because, well, whereas the bucket size changes, we only have pointers to the buckets, right? And allocator is always the same size and count is the same size. And so I, as the author of the program, know that I can index these anonymously. And so this is like, oops, this is just like a setup where I can index them anonymously. And I'm not sure why I said type erased bucket array here. That's not really necessary. Because that means I have to cast it to the right type later. It's fine though. Anyway, that's how we do it. And then, you know, there's a for, you know, you can do for loops on these, right? Here's the for loop for bucket array. And, you know, the whole file is 150 lines. So in general, one very big difference between this programming language and most programming languages you'll see is that I'm a big proponent of keeping the core code very small and very simple and very focused and only doing what it needs to do. And so all our data structures look like this. Like this is one of the core data structures we use in the game. It's 150 lines. Because like it shouldn't be 5,000 lines, right? So yeah, okay. For various reasons, you sometimes need a physics engine that uses float 64 for everything. This is fine as a module parameter. However, because float is float 32 by default, when you make that change, all floats in the physics that you try to pass in the drawing function, the gameplay function, then need to be manually casted. Well, there's a few approaches to this, and we're still experimenting. Right, so what he's saying is if you have a function f and it's in some module, it's a language feature that you could say in the module, hey, instantiate this whole thing with the type being float 32, or instantiate the whole thing with the type being float 64. I'm going to turn on my stupid fireplace over here for a second. I'm cold. So you can do that, but now you've changed the return values of the functions in the module if they returned one or the other type, right? And now the rest of your program has to deal with that, and then how do you do that? And like, that's kind of something you have to decide, I think. I'm not sure that we can help you that much. But the other thing I would say is, you know, there's sort of this idea, like instantiating a module as float 32 or float 64 seems like a natural thing, but I don't think that specific example is that good of an idea. And the reason is because unless the module is very carefully authored. And the reason is, for example, why do you want float 64? Well, it's got more precision. Okay. Some of that precision you get for free, right? Like, hey, you multiply big by small and divide, and the bits are still there. That's great. But certain classes of numerical algorithm are written by people who know what they're doing to yield certain numbers of bits of information, either total or per iteration or whatever, right? And so if you just use some of those, but now you're in float 64, you're like not necessarily getting the bits that you thought you were, right? So that's just another thing to think about. But yeah, so if you're going to change the return type of a bunch of stuff in a module or the parameter types, yeah, now there's a discontinuity between that and the rest of your program. And you could author the module like, okay, if the main reason you want precision is for intermediate computations, which is possible. It's possible that's all you really want. Then you can just have some stub functions at the bottom that downcast to float 32, and they're no ops if it's instantiated as float 32, right? Or you can just write the cast either way. But like, I'm not sure that there's anything more magic to do there, because the reality is if you instantiate this thing as float 64 and it returns float 64, you're claiming that those bits are useful. So now again, if you try to shove those into a float 32 somewhere, you're dropping that precision, and you should be specific about it. If, on the other hand, you don't want to return float 64, but you only need it internally, then you should maybe write the module that way, right? So the module could just have the return types of things be float 32, and you just use float 64 internally if you want. Like, that works too. It's like, I don't know enough about your specific use case to really know. Any plan to support the more specific version of an overloaded polymorphic procedure? The more specific the current behavior is, okay. Yeah, like, see, here's the thing is these discussions come up once in a while when people say, let me type in what the question is here. Okay, so he's saying we have two overloads, right? One of them is this, and one of them is, right? And he's saying, well, look, if I call with an array of something, obviously it should pick this one. And it's like, maybe. This right now is an ambiguous overload error because the scoring doesn't work that way. The scoring works on like how many polymorphs are there, how many implicit casts are there, and all that. And so these score the same because they have one polymorph to figure out the type of T on each one. So now, could there be a different scoring mechanism? Yes. But like, it's not a kind of a thing where you want to make a lot of incremental small tweaks, I don't think. And the reason is because when you write this program, and the program would have a bunch of other overloads and stuff. I think programmers need to really understand, like they know that something's going to work and they know why it works. And they could tell you even what the scoring is that makes it that you actually pick this one, right? Now, it might be that, well, because you already sort of think about the syntax tree in this language, then, you know that this is a type and this is like a sub branch of the type, and we matched on this part, and so that's more specific. But like, can you codify that? Can you write down what the matching scheme is that does what everybody wants? And if somebody can come up with that, or if I can come up with that, then sure, we can change to that. The thing that I did is literally an extension of the first idea that I had for simple cases. And so, yeah, if there's something smarter, we can do it, but I don't want it to derail into a weird black magic thing with a bunch of exceptions and weird if statements and stuff, because then people will never understand it, right? And so, this is already really sus to me because it's easy to accidentally write infinite loops with this kind of code. And so, I don't love this. But should we be able to tell the difference between these things? Maybe. If somebody wants to propose what that system should be, I would definitely listen. But yeah, so as other people in chat pointed out, we do have a mechanism for making this work. It's just more verbose, right? You put a modify directive, and from this one, you would reject arrays. And that makes these, like it would, I'm just off the cuff, right? But let's put the procedure bodies too, like, okay, these are empty procedures. And if in this one I say, type info of t, and if return ti.kind is not equal to array or something like that, right? So now when you go to do the overload, this one will reject arrays, and that means that this will resolve. This is a little bit verbose though, and so I interpreted the question as being, why doesn't this work without that? And the answer is because of the reasons that I just explained. Okay, people say they're liking the longer answers. They said this half an hour ago. That's fine. What is currently the simplest way to iterate through the members and values of a struct? Oh, there's examples for that. I feel like people can point you at examples for that. I've done it a bunch of times on stream, so I don't want to spend time on it. Let's just write, you know what? Screw it. We're in long answer mode, right? Let's just write a whole program. Da-da, da-da, da-da. I'll show you the easiest way. Wait, did I want this? That's a bug report that we haven't fixed yet. We can get that back. Okay, so we're going to use basic. We're going to say a thing is a struct with a name is a string, a value is a float, and whatever is 100,000 void, because that looks like a face. Okay, so we're going to have a main, right? We're going to have a thing, and we're going to say talk about thing, right? Okay, what does that do? Talk about is thing is something. We don't know what type this is, right? Because we want it to work. Let's call it X because it's not a thing. It's whatever. And we're going to say this is a type info of T, just like I did in that modify. This is a type info struct, which is why I put this S here. You can look up in the compiler file what that looks like. Type info will cast to the most specific subtype of the thing. So if I only pass structs to this, which I'm going to do for now, like again, I could put a modify here that has boilerplate that rejects anything that's not a struct, or I could do it here at runtime. But yeah, I just want, for the convenience of a short example, we know this is a type info struct, and I'm just going to say for tis.members, right? We're going to print the name, colon, the type, right? Now, okay, so first, the type is just going to be a pointer. So, but just to show you the bare minimum, we're just going to print this, right? Okay, so did I forget something? No. Okay, so here we go. We have the name. In fact, we can print so here's the name of the struct, and here's the things. So now types, well, how do you print a type? Well, types could be complicated, but there's, you know, there's a function that, oh, it's in BASIC, right? The print function already handles types, right? But it does it to a string builder, which is a little bit interesting. Oh, we have type to string right here as a helper function. All right, so type to string it.type. I forgot about that. So there we go. That's just how you do it, right? That's the easiest way to do it. I'll put that back up. You know, we type that like in a short amount of time. It is what it is. Oh, look, I'm actually down toward the bottom of the questions. Game audio is really loud. Okay, everyone's complaining about sound. That's great. When a compile error happens at the end of several function polymorphs, D will show the function polymorph parameters as part of the compile time stack trace. Is it planned to add this? No, we should be doing that. It was a little bit inconsistent, but I want to say a month or two ago, a change was made such that that should happen for all error messages. Like it used to be case by case, right? And now it should happen for all error messages. If that is not happening, send in the example, because it's very important for error messages to be good. Okay, while we're talking about fixing historical things, one of the things that's historically terrible about compilers is when they say there's an error in some location, and that location isn't the thing that you were just working on, and you have no real way to trace it to anything you were just doing. And so now you're kind of lost, and you're just starting to, like, now I have to go on an expedition to figure out why there's even an error message, right? You don't ever want to be in that position. You know, older compilers would do that all the time. Newer compilers do it sometimes just because languages these days have more in the way of spooky action at a distance that can cause that kind of problem. But we're doing our best to not have that kind of problem. Yeah. We are at the bottom of the questions page. Someone's asking about the bug reports. Do you have duplications for bug reports? Am I okay with structures of reports? Yeah, the way people are reporting bugs is fine. I mean, the biggest problem is just that I'm a little bit behind on addressing them. You know, usually the easy ones get nailed right away, but sometimes they take rewrites, and then we go through bursts of me spending more or less time on my compiler, on the compiler, because there's more or less of my time on the compiler is what I was trying to say. Because there's just other projects. Like, if I was even working on this compiler full time, and not doing anything else in life, it would be fine still. But right now, it's a little bit hard. Like we're getting a little bit behind. So the plan for that eventually is that we'll hire another person or two onto the compiler team. But that probably, we shouldn't be looking to grow the company until toward the end of the year. So between now and then it might be a little bit slow to get to some of the bugs. But usually, like there's two ways of prioritizing bugs, right? One is it easy to fix? Let's just fix it. And two is it really bad and affecting a lot of people? Let's prioritize that. And so I think we do an okay job at those things. And so the real thing is just like, well, there's these issues that once in a while, they don't affect a ton of people, but we should fix them. So one example, actually, this program that I just deleted, I don't want to Control Z back to where it was, but it was a dude filed a report like, hey, I called compiler get nodes on a function, and I didn't get the types of the function parameters back in there. They were all void. And I'm like, oh, why is that? And then I remembered, oh yeah, it's because there's this whole thing about the way compiler get nodes works. There's like a tactical problem where we have to copy things and erase the types right now. And we could then reinfer them, but that would make a mess. So it's like, but there's a known solution to that, and it's actually the way things used to work. Okay, the type, I've talked about this on stream before. The type of a node in this language is stored on the syntax tree node right now, which is like fast in a lot of ways, right? Now, not only that, but when we export to you information about the node, like the user visible version of the node, that is also on the node next to the type, all right? What's wrong with that? Well, the way programs are DAGs sometimes. You could have multiple things pointing at the same thing, and you don't want to, like, when you go doing a deep copy of these nodes to send them to the user, you don't want to accidentally send multiple copies of those things. You want to deduplicate those copies. And how do you do it quickly? Well, if you just say on the node what it's exported to the user pointer is, you could just return that. The problem is, for a function like compiler get nodes, the way we advertise that people could use it, even though not that many people use it this way, but we sort of advertise that you can get the nodes back and just screw around with them and submit it as new code. And we even have examples that do that. And so we can't like return you old exported nodes as the result of that function, because it would just produce wrong answers, right? And so, so we need a way to not, like, you need to sort of have a way to say, we're going to do compiler get nodes on this thing, and we want to have this DAG thing where we point at the same nodes, but we don't want that to have to do with anything old. And that doesn't really, as soon as you only have one slot to store what the user exported thing was, because it's stored on the actual syntax tree node internally to the compiler, you can't really do that operation, right? And so that's an example of a bug that's more effort to fix, because it's like we have to change the way something works fundamentally. Now, fortunately, that one's not that hard, because, okay, this has gone back and forth. It used to be that the exported nodes were stored on the compiler nodes. Then at some point, I made it a hash table in the message exporter, because I said it shouldn't be that much slower, and we want to reduce the node size anyway, and it's like better for memory locality in most of the compiler to not have that data there, right? And it was a lot slower, but I was stupid. Everything in my programming career has taught me that, like, when it's slower, maybe it's stupid and you should investigate, and I didn't do that. I just said, oh, the hash table must be slower. It turns out I didn't understand hash tables as well as I now do. And we were getting a lot of collisions for reasons that is obvious to me now, but were not obvious to me then. All these reasons are documented, by the way, in the hash table, because these went into the design of the current hash table that we ship, both internally and externally in user code to the compiler, and it's all explained there. But we were getting way, way, way more collisions than we should have as the table got big, and that was bad. So But I didn't profile the hash table, right? I didn't ask questions like, how many collisions are we getting per insertion? And is that what we expect? I just looked in telemetry at the total time being taken by the hash table and said that's too many milliseconds, right? Lesson for you though, that's not really profiling. Profiling is like asking why and figuring out why. And I didn't do that because, like I said, I just have all this work to do and like, let me just go work on something else. So I changed it back. Now, the thing about using a hash table internally for something like that is you could just push a different hash table. You could just say, okay, all the nodes that have been already exported to the user are here, but we want to do like a fresh thing that does have node deduplication, but only for itself. So you just push a new hash table, say, this is the new table where you look up what we've already exported. And then when we're done with that export operation, you just erase that table and go back to the old one. And so fixing that bug, wow, this has nothing to do with the original question. But fixing that bug just involves going back to that implementation that we already had, but with a better quality hash table, which we now also already have. So, but it's not trivial, I guess was the point. And it doesn't affect a ton of people. So I was like, oh, it'll be fine if I take a few weeks to get to this, right? That's sort of like how I classify, and that's the current situation. But yeah, the plan is, so here's the thing, assuming we continue to be a successful game development studio, we should be soon, where soon is a year, coming out of this long desert of not having any money because, decided to do a game that ended up being much bigger than we expected. And we made an engine we just decided to make a much more complicated engine than was my original plan. And it's in a new programming language. And all that stuff is just like, you're not making any money while you do all those things. And as a result of not making any money, it's just like, you can't hire a bunch of people to do stuff. It's not reasonable, or you'll just go out of business very quickly, right? And so we don't have that many other people to work on the compiler. But the plan is, around the end of the year, we hopefully will have money to do that. We're still hiring in other departments, but the difference is the game is an expected revenue generating thing, right? And so you can hire for that. But the compiler isn't really. So, yeah. Hopefully we can have more velocity on these later on. But we're not that far behind. I mean, all this stuff I said about being behind a little bit is like, I think I nail 80 or 90% of bugs as they come in. It's just that 10% that's left over piles up over time. And then you look and it's like 200 things because it's been a couple years and you're like, oh man. Was there a way to call a function in an ASM block? There is not currently. No, but the thing is that the contents of ASM blocks string together. They can refer to each other's variables. So you would just close the current one, call some stuff, and then open another one, and you should be able to just continue it as though it were the same ASM block. If that doesn't work for you, again, you could file a bug and we could talk about it. But it's just like, it's essentially the same thing as what you're asking. It's just syntactically different. Like, does the function call go inside or outside? Would it be a bad idea to ship a complex game to Steam completely written in the language right now? How about in 6 months? Do you mean bad idea for you or me? I mean, for me, it's a bad idea because our game isn't done. For you, I don't think it's a bad idea. Like, there's nothing, like we're still evolving the language and we may change some things, but we take great care not to break things unreasonably. And I think for a long time now, we've been past the threshold of like, how good does the language need to be for you to ship something on Steam, right? So I don't think there's anything inherently wrong with that. I would encourage people to do that if they want to. For our part, our game just ain't done yet, and so we're not shipping it yet. What do I think of having ways of using the compiler more as a toolbox rather than presuming the user is trying to compile a program? So you could manually call the lexer or generate lexer data manually. I mean, yeah, we can start doing that. I'm just a little bit loath to start doing all that stuff right away because um, it just increases complexity and maintenance burden a little bit, and I don't want to increase those things until, um, like, there's still a little bit of the language that's still in serious evolution. Like, I'm not totally happy with where macros are right now, right? And I want to make those better. I don't exactly know the answer to how to make them better. And like, I'd rather be working on problems like that than making the lexer reusable, um, for example. But yeah, there's no, in principle, long term, there's no reason not to do that. One of my frustrations with software is when it's available in executable form, but not library form, right? So like, I've got some great string search program on my machine, but I'm writing code and I can't search for a string without installing a bunch of weird shit. You know what I mean? Like, that doesn't make any sense. It's a sign that we've gotten something wrong with computers. So, unfortunately, what that means in the C++ world is, exporting a bunch of libraries of different types, and then people will complain that they can't link them correctly and all this shit. And I don't want to deal with that yet, right? That's all. But that's the only reason. So I am down to the bottom of the questions. So here's the thing. If beta users have more questions, they could put them right now. And if it slows down a little bit more, I will brave the Twitch chat and we can see what's happening there. Assuming that we're even live still. I don't know. How difficult would it be to target consoles? Not that hard. Again, it depends on your particular console and all that. We've done it before, but only with trivial programs. Because we're going to ship this game on consoles, we're in the process of getting serious about that, but like, we're at the beginning of the process of getting serious about that. So it'll be a while. Any chance that we get a how-to for directives? I mean, so here's the thing. So for reasons that I explained at the very beginning, which, maybe you weren't here for that, but there's some things that probably shouldn't be documented that much, or we shouldn't spend time on. And so the question, please document all the directives, isn't that good, because it just gives me a lot of grunt work to do, and a lot of it isn't that important, but some of it is very important. So what I would prefer is if people got together and sort of said, these are the specific directives that we're wondering about, or is there a directive to do the following thing? And then I could document that. Like, I could document the things that are actually of concern to people and focus the effort, right? Because there are a number of directives that are just kind of stupid and temporary, for example. Have I thought about expanding the namespace of potential operators? Kind of, but not really. It's just like, that's one of those features that seems like a toy to me. Because, again, my experience with C++ was I hated operator overloading the way most people used it in C++. So like, why would I give people even more power to do that than C++? I mean, it just, And I even, so standard ML of New Jersey, one of the languages I used in my formative years, had this thing where like every 2-letter identifier was an operator, right? And it's like, okay, that's funny and it's cute, but like, does it really help you solve problems? And this is the thing. Whenever people, this is why there's a syntax suggestions channel on the secret beta that I only pop into occasionally, because a lot of the time when people have ideas for your programming language, They're ideas like, wouldn't it be cool if you could do this? And sometimes the answer is yes, it would be cool. And sometimes the answer is no, it wouldn't be cool. But regardless, neither, whether it's cool or whether it's not cool, is orthogonal to, does this help you solve any of the real actual problems that are holding us up in software engineering of the complex systems that we face today, right? And very few people are actually working hard on that, because most programming language design is wouldn't it be cool if, right? And yeah, I mean, sometimes things are cool, that's great, but it doesn't help me ship my game faster, right? So how do we ship the game faster is really the question. Are there any plans to allow getting the bytecode of a procedure in the code itself? I've thought about that a little bit. The thing is, again, we would have to bloat the output. Like, you know, I like to keep header files small. Maybe that could be defined in a different place that you don't. I mean, there's no header files, but like module files. Maybe that could be defined in a separate place that you don't import if you don't care about it, so that's not a big deal. Just maintaining that correspondence. Like we recently, where recently is like a freaking year ago. But at some point we changed the memory representation of bytecode anyway. So like this whole thing would have broken and had to be redone at that point. And it's just, okay, so going back to an analogous thing, right, which is the syntax tree nodes. When we export that data to the compiler, or to the user metaprogram, sorry, from the compiler to the user metaprogram, we don't give you the picture of the nodes that are internal, because those change. We need to change those for implementation reasons, right? So it's essentially a copy, and that has two consequences. One is it takes CPU time, but again, maybe we can work it so it doesn't take time if you don't request that. For bytecode, that's easier. For syntax tree exportation, there's kind of some reasons why we have to pay for it either way, although maybe those changed. I'm not sure. I need to think about it. Okay, and then the other one is we have to maintain that abstraction at user level. Because, so the whole reason, right, the reason we don't want you to be looking at, when I say we need to be able to change internal compiler representations of things, why? Because we don't want to break everybody's program in the universe just because they try to do metaprogramming or whatever, right? And that was actually something that not everybody understands the importance of that, but it's very important, and it is worth spending CPU cycles on and memory on. Now, just so adding one of those for bytecode, it's like, could that be useful? Yeah, it could be useful. Would people be able to use it as much as the syntax tree stuff? I don't think so. I think it's more of like a niche enthusiasm thing. Like there's definitely, like making code analysis tools and stuff. And I just said before how much I think understanding a program is important. And so it would help with that. It would be another way that you can understand your program. And I think that's good. But it's just outside that. I'm not sure that it has a ton of use. And so it's just one of those things where the cost benefit analysis says we do it later, because again, now the progress on the compiler is gated by complexity, and complexity just means the number of constraints you're subject to anytime you try to do anything, right? And you know, if we add prematurely this thing that's about here's the bytecode abstraction that we are now declaring that we will maintain until the end of time, right? That's more friction on everything else that we do. And I just would rather do that later than sooner. All that said, what I've just explained is my internal rationale for this, absent any external input. So if somebody came to me and said, hey, if I had this, I would do this and this and that cool thing. And if those things seemed really worth it, it would alter that decision-making calculus, right? But for now, that's the story there. Any thoughts on how debug stepping can work? I don't know. I mean, this is one of these things where, again, like debuggers are kind of old and crappy and broken, and we already have problems where they don't understand things that we want to do with macros and stuff. And back in the old days, that wasn't that big of a deal because, you know, you would just, you know, the guy writing the debugger would be in the office next to yours, and you would say, hey, Al, let's change this. But now it's cemented into these very complex debugger file formats that also just don't do that much, weirdly, right? And also, because very few people do interesting things in terms of outputting to these formats, it's very hard to find out on the internet, like, can we even, is there some weird way to express this thing inside this debugger format? So I think it's all stupid. Like, I wish debuggers worked a different way where they were like on a plugin model as opposed to trying to have this file format that represents what programs could do in the 1970s. You know what I mean? But I would, you know, it like some of the stuff Raphael just did was, you know, whatever hacks we can do to make stepping through macros more reasonable, for example. And so we're definitely interested in improving that. It's just, it's one of those things where you run up against a wall of existing tools that aren't very good. Like, so one of the things, you know, one of the things he told me was like, okay, in CodeView, there's supposed to be ways of expressing certain things, but because no compilers did that, the debuggers all don't do it anyway, right? So like they break on certain inputs that they should theoretically handle because nobody ever gave them that inputs and insisted that they work. And like now we're not going to get Microsoft to like fix that, I don't think, right? So it's just hard. But if there are things that we can figure out, if anyone is really good at debuggers and wants to talk to us about how to improve our stepping experience, maybe we should call up George from Remedy, for example, and just say, what can we do here, right? That would be a good idea. If we're in the mood for more code examples, could you show an example of how to achieve this? Let me see, base type A. See, I'm looking at this on one laptop and I'm on another one, so I don't want to, it's a little bit more than I want to type in, but let's see. Type A is a struct with some stuff. It's using the base type. API, you know what, let me just, I would prefer to read it here anyway. All right, so we're running the Discord. I'm doxing everybody. I'm copying this. I'm closing it. All right, so first I have to understand what you're asking before I can like answer the question. All right, so we've got a type. It's using this base type. We've got an initializer, which is a foreign function. So this isn't even going to compile, right? Because this isn't a thing. It takes an object with a member name and a member pointer. And then init thing takes something related to base type. Call API init initializer for each int in T. I mean, dude, that's easy. We fucking just did that. I mean, this is, all right, so, but you want it to be a little different. So there's two ways you can do this, and I'll show you both ways. First, let's make sure this frickin' compiles, right? Okay. So right now, this doesn't do anything. Let's make sure we don't crash. Okay, so way number one to do it is dynamically, but you actually want to generate code, but that's like sort of one step beyond the dynamically. So let's do the dynamically part first, right? So here we're going to say basically the same thing we had in the other program. We're going to say this is type info of T for tis.members. Let's just say int info is type info of int. All right. If it.type is not equal to int info, continues, because we only want ints. And now we'll say, so first let's just make sure we got it right. So we'll say, so by the way, this thing that I'm doing here, I'm doing it step by step. This is also the way I would do it if I were writing this program myself. It's like I have this target of doing like a code generation thing, but let me do the easy part and just, or not even the easy part. Let me just get it there before I make my life difficult by like adding the static generation step, right? Okay, so it.name, right? Okay. We've got to actually call this. So I'm going to say thing is a type A, init thing of thing, right? Okay. I messed up. Type restriction does not match. Oh, because this has to be like, this isn't the way using works anymore. That has to be an as. All right, we didn't import basic. Bias. I'm bias. Basic. Okay. Here we go. V0 is an int, V2 is an int, done. Okay, great. So we got those. If you also want to iterate whatever's in base type, there's a little bit more, but whatever. It's just some variant of this. All right. So now instead of printing that something's an int, okay, well, the dynamic version is this. You just say API int initializer. And again, this is an as, so we could just pass thing and it.name. And okay, we have to get the pointer, which is, we have to compute that, right? And the pointer is, I believe, so let's say base, let's put this outside the loop. Base is cast pointer to U8, or it could be void. Let's make it void. Of thing, right? So that's the base address of the struct. And then down here, we're just going to say pointer is base plus it.offset in bytes, right? And then we're calling this function, which doesn't exist yet. So let's make this exist. Instead of it being foreign, we're just going to do this, right? Pretend it's in a library somewhere, and we're just going to say, here's the pointer API object. We're going to do the name. Let's put values in there just so we can make sure we're getting the right thing, right? So API object, right? We've got member name and member pointer, but we want to dereference that. So we'll crash even if we're wrong. And then let's just say when we make the thing, we'll set the ints, right? Thing.v0 and v2. So thing.v0 is 42, thing.v2 is 69, 105. Cool. Now, I'm sure I forgot something, but let's just see. Let's let the compiler tell us what I forgot. Huh? No? Okay, so now we're calling this function and printing out the values of the int members, and that's fine, okay? So the next step, though, is you wanted to do this, where you're generating code that is static. And the way that you do that is you can start with code. So, okay, just to explain to people who aren't in the beta or maybe don't use this language, right now, what is happening is at runtime, when we call main, right, we're making this object, we're going down into here. This function was created at compile time, but it doesn't run at compile time. And then we're just looking at the type info, which has been packed into the executable for this struct, and saying what are the members, and there we go, right? Okay. Now, how do we take it? The thing about this, I guess I would say, is, you know, you're iterating at runtime and you're ignoring members and stuff, this isn't like the tightest code, and it can't be like inlined with other stuff and whatever. And so if the question is like, how do I generate static code that's going to be efficient, then you take it to this next step where you do this, where I'm going to insert as a string. You could insert nodes, but like we don't have enough helper functions for nodes to be awesome, I think. So it's easiest to just build a string. And also you can print out the string. We'll probably do that. Okay. So now this is going to run at compile time because this has an implicit run there, right? But when you say insert arrow, it's got an implicit run, right? So now all this runs at compile time, and I could show you that actually. Actually, let's just leave it. Yeah. Backslash hello sailor like this is why we have here strings. Okay, I messed up. Wait. Okay, hold on. Because this is just insane. This is why we do these things. All right, so we're going to say return to, let's call it to insert. So we're not trying to insert the actual code yet. I just want this to run. I'm just going to show that this runs at compile time, except I messed something up. Oh, shoot. Right. Oh, right. Okay. So the base address of the thing is a runtime element. So we're going to factor that out. All right. And then here, let's modify this a little bit. Instead of calling this thing right now, because we're trying to pass it with just the pointer, we're going to fall back for a second and just print the name and the offset. And then we'll convey that into a thing in a minute. All right. Member name. Wait, where did I say that? Oh, duh. Because here it's it.name. I was staring right at it. Okay, so now look, we said compile the program. These things happened at compile time, and then we inserted a string. And that's going to be the last step, is inserting the right string. The string we inserted instead was this. So now when we run the program, it prints hello sailor, which is not what we wanted. What we wanted was this, right? So now we just do that last step where we say, okay, we're not going to return to insert anymore. What are we going to return? We're going to return builder to string of something that we built, right? We're going to declare that. And I'm going to say, for each of these members, we're going to say print to builder. The format, which I'm going to declare down here, where this was, so that we don't go insane, right? And then the arguments, which are the name and the offset in bytes, right? And so what is the format going to be? The format is what we want to insert. And that's just going to say, well, this, instead of this, I'm just going to say base, right? Because we're based. And then we're going to say, oh, wait, hold on. Yeah. And then the argument for the name. Now this looks like it's in quotes like a usual print, but this is a here string, so these quotes like aren't quoting things, right? So we print that, and then we want the offset in bytes plus, or he wants the pointer here, right? The address of this thing, which is just going to be base plus whatever. So, and we could even put numbers on this to just help us know. So this is going to be the first argument, and this is going to be the second argument, all right? So now over here, yeah, I mean, that's basically it. You could cast this to a pointer to int, but I made it a void pointer, so it'll auto-cast. So you don't need to worry about that. Okay, so now we actually need this to come back because we're trying to call it, but we're not calling it here anymore, we're calling it down here. So I probably forgot some things again. No. Okay, there you go. We're done. So now this runs at compile time, it generates the code, it gets printed out, etc. So now I could show you the code that was generated, right? Probably here. This is where we just run, yeah. So here you can see this was generated from line 18. I think we have a bug that this line might be, no, there we go. So this was generated from line 18. Here's these two lines. So that is how you do the thing that you were asking. I hope that wasn't super boring for everybody else, but it was the last question. I will clean this up for a second and paste it back into the Discord so that you have the answer. Well, we can leave. Actually, this documents the function, so let's just put it there, right? Okay, cool. So I'm going to pop back here. I'm going to go ting, ting, whoops. I'm going to go ting, 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 ting. What just happened? I just tried to type into the thread and it opened and it closed. What literally just, did I tap escape accidentally? Okay, there it is. Instead of base dot plus x, you could print address of thing. That's a good point. Let's do that version. So it is true that we could let the compiler figure out the address frickin' anyway, right? So we don't actually need two parameters in here. We did for the dynamic version, but we don't for the static version. So what we could do is just say address of thing dot %1, right? We can use the same argument twice because our print functions let us do that. Yeah, in fact, I should have done that. That's actually one thing, because you could be in the dynamic mindset when you start with dynamic and then forget to do that. But there we go. So that still works. And it's nicer because you only have one argument, right? And so just to show, we go back to the added strings file. And now instead of base plus whatever, we're saying address of thing.v0. So, yeah. He's saying totally failed to see the dynamic version and went straight for the static version. Yeah, well, that's the thing. So I like to minimize how many problems am I trying to solve at the same time. And so if I'm trying to do something from scratch like this, I'll do dynamic first because it's just a little bit easier. I don't know, right? Than trying to, because when you're trying to be static at compile time, just some things are not compile time constants and you have to balance that. But once you get used to it, it's pretty easy. And honestly, once you have one example like this, like now, anytime you want to do something vaguely similar, you just paste this example and change it or whatever, or factor it into utility functions that you could use or whatever, right? So instead of rejecting int or not here, right, or rejecting if it's not int, you have some function that says, do I care about this member? And you can call that and all these things. All right, I've been going for almost 2 hours, but we're out of questions on the Discord. So I think, although, yeah, I'm just making sure. We also have a questions channel, but I'm making sure people didn't go there, and they didn't. Someone says, the Misera examples in the how-to shows a static analysis program which constructs a call graph in order to detect recursion. However, if there are multiple metaprogram plugins checking different things, they'll likely end up building their own call graphs, control flow graphs, etc., and duplicating work. Would it make sense for the compiler to provide these sorts of analysis structures? Well, okay, this is a big question. Sometimes when there are questions like this about how do big pieces of user code coordinate with each other, I prefer to punt on that until it's a real problem, because a thing that happens a lot in programming is you pre-solve some of these things, but the solution isn't right because you weren't really contending with the real problem. You were programming a hypothetical solution for a hypothetical situation, and then the real situation doesn't have that much to do with the hypothetical situation, and so on, right? And so I prefer to wait till that happens, and then when it happens, I would prefer for it not to be built into the compiler that somehow it gives you a control flow graph, but like, well, okay, actually, no. Two things. So one, if you're talking about general data structures that are in common between things, I would rather have that be a user level module that people standardize on using, because then people could choose to use it or not to use it and all that. Now, when it comes to the control flow graph specifically, that might be something that we want the compiler to give you, because the compiler knows the right answer. And anytime, it's like if you're parsing the grammar or something, it's like, okay, this is your code's opinion of what the parse of the grammar is, which might diverge from the compiler at some point, right? And even if it doesn't, it's annoying to get there. And so that might be the kind of thing that the compiler provides. But in general, these coordination problems, I would prefer to get solved at user level, because again, you can't put literally everything into the compiler. Like that's not a good way to go, I think, long term. How is Twitch chat going? How is Twitch chat going? The text is very small. I don't know why. I have this Ubuntu laptop that I was forced to use when my power supply died, except I wasn't, because my laptop supported USB charging, but I didn't know that. Yeah, people are talking about compile speed. Yeah, so the compiler, like I said before, got twice as slow. I think I kind of know what change made that happen, and it's a change we can revert eventually if we really want to, but it's one of those things where like maybe what I'm doing now is inherently slower, or maybe maybe it's a stupid bug like the hash table. I still don't know and haven't had time to investigate. And so, you know, when you see these compile times though, yeah, these are compile times while most of my cores are streaming video to the people. And, you know, so here, this front end time, 18 months ago, like the game code was simpler 18 months ago also, but it wasn't that much simpler. And this front end time was like 0.6 seconds, I want to say we had it down. Well, that was on my desktop. So I think it was like 0.8 seconds on this laptop. When I'm not streaming, this is around 1.55 or 1.6. That's the front end. And then you add this, and then, you know, that gets us up to like 2 seconds. So we're not doing, I mean, we're doing way better than most other modern languages, but like we're doing 130,000 lines per second, whereas we did hit 250,000 per second before. So I do take this seriously. I want to get us back. So first we have to get back to 250, and then we have to get to 1 million. Back to 250 is not that hard, I don't think. It's just priorities. 1 million, we could probably get to 1 million just through grunt work, not by redesigning the compiler, but that's not really a smart use of anyone's time. Like the good way for us to get to 1 million is to parallelize the compiler. But 130,000 lines per second on a laptop, which is where we are right now, is, I believe, a lot faster than a language that calls itself Swift, for example. I don't know why they call that Swift. They should be sued for false advertising. How much Unicode support is there in the default string type? 0. 0. The compiler has no opinion. What is called a string is bytes with a length. It does not care what you put in there. That's more of a user level thing to care what you put in there. Has link time gone down? I don't know. We're certainly linking a lot more stuff than we used to once upon a time because this frickin' audio library that we use. This is the Sokoban game, by the way. This is, you know, the biggest workload that we have in terms of the most lines of code and then linking the most external stuff and whatever. But like half of the link line is this one audio library. Well, not half, but everything, I think, unless there's something buried in the middle, everything from here down should be one library, but it's like a million. It's, 40% of it. But I don't know, like to the extent that it's faster, I'm not sure. Another thing is, I think my laptop SSD might just be degrading. And so maybe that's a reason why compile times got slower. Like, I'm really not sure. Is it possible to gain access to the how-to guides to read them? I would prefer to just keep that to beta people for now. I mean, we could just throw it on the internet, but What is the largest compiler feature I'd like to work on this year? I would like to make progress on parallelizing the compiler, and that is a big thing. But that would be my answer. WISE is pretty whack. I know. We wouldn't have used it except the audio guys who we are working with, who are very good at what they do. That's what they're used to using, and they were like, we can do our best work in this thing. And I'm like, I wasn't about to say, well, we're all overworked and don't have enough programmers, but just use whatever we happen to throw together. No. So I was like, we'll let you guys use that and we'll deal with it later. The problem is I also have the agenda of making these games be able to live a long time. Like in 50 years, people should be able to download the source to these games and build them, which means I have to give out the source at some point to Braid and the Witness and this. But it also means that we should minimize our dependencies on stuff like WISE. So what this means is like later, we're going to have the task to fucking port everything off of WISE and maintain the same sound, which may be very hard, but it's necessary for longevity of the game. Would it be possible to use the language for web development? I mean, you could. It would be much more of a back-end thing than a front-end thing, but some people have tried. Some people have tried cross-compiling to WebAssembly. It doesn't 100% work smoothly yet, but again, I've got one of these backlogged bugs in my email where somebody just sent me like, oh, here's the latest problem, and so we're working on it. Would 1 million lines per second still be possible while generating debug information? This timing that you just saw does generate complete debug information. So we're at 130,000 right now on a laptop that's streaming video, compressing and streaming video. And like I said, we used to be at 250, right? So can we get 4x faster or 8x faster than we are now? Yes, easily. Well, not easily. Easily in a computer science sense, very difficult because it's just the answer is just use all the cores that you have, but it's hard in an engineering sense. You'll do that WISE port job in a heartbeat. Email us then. We wouldn't be ready to do that for a while, but we need to do it eventually. Why is string a special type instead of just a slice of bytes? Because it's the same reason that we have different names for int and S64, even though they're the same thing. Sometimes intent is useful. Like that's the only reason. It really is. A string and an array of U8 are literally the same thing. But communicating intent is good, I think. But then this also introduces problems sometimes because functions can take one and not the other, and then you have to cast it and whatever, but it's fine, mostly. When will be the next big beta expansion? I don't know. Like, I want to keep the beta growing at a healthy rate, but I also have stuff I got to do right now. So we'll see. We'll figure it out. I mean, we should. So we have around 350 people right now. We should at least, if we don't double that in 2023, that's not good. Ideally, we more than double, right? But we should have more than 700 people at the end of the year, right? 700 is the lower bound. Let's put it that way. 700 is like if we just don't do that much. Or maybe nobody wants to use the programming language and we say, hey, everybody, and only 699 people show up. That could happen too. Okay, well, um, that might be it for now. I think we're in the habit of doing one of these beta Q&As per month. So we'll probably do one at the end of February, although that's a short month. We'll see. Might be beginning of March. Thanks for hanging out. We haven't really streamed very much. It's been a good brain break for me. We might stream some programming again soon. We might not. I'm still on my little laptop here in my new apartment, and so who knows what's going to happen. But thank you everybody for coming by, and